Hello guys, welcome to H2O, the A to Z of chemistry. I'm Dr. Ritu Johar, your educator for this course on hydrogen, and I hope you are enjoying this course with me. Today we begin with lecture 5 from the course, but make sure you watch the previous ones before viewing this one. In the last lecture, we talked about the different forms of hydrogen, the atomic hydrogen, nascent hydrogen, occluded hydrogen, the nuclear isomers. We talked about so many things. Now, I hope all that you have learned in the previous lecture that is clear to you. In case you still have any doubts, please feel free, put your doubts in the comment section. You can also email them to us. The email ID of ours is always written on the last slide of every lecture. Do not keep your doubts to yourself. Just pass them on to us. Clarify your doubts, and please, that is the only way that you are going to excel in your examinations. Okay, now moving further today in this lecture, we are going to discuss about the preparation of hydrogen. And when I'm saying hydrogen, what I'm referring to over here is H2, that is dihydrogen. Okay, so the different ways in which we can prepare hydrogen is by the action of water on metals, by the action of dilute acids on metals, by the action of water on metal hydrides, by the action of alkalis on amphoteric elements, the laboratory preparation we will be discussing, and the industrial preparation of hydrogen we will be discussing. So these are the 6 broad headings under which I am going to discuss with you the preparation of hydrogen. And why I have written down all this is because when you will be revising all this, these headings are under which you have to write all the reactions. First learn all these 6 headings and then one by one keep on writing, practicing all the reactions which are going to be there. This is the only way in which you can learn inorganic chemistry. Keep on writing the reactions again and again. Okay, so now another thing which I want to tell you is that this topic, preparation of hydrogen, is very important from the examination point of view. Many of the examination questions, these are coming from the preparation of hydrogen. So wherever the questions coming are more from the previous year examination papers, so I'm telling you along with that these topics, they should be done thoroughly. Do not just have little bit of knowledge over here. Each and every concept, learn that very well. So the first method by which we can prepare hydrogen is by the action of water on metals. And here, please do remember that the reactivity of the metals is going to play a very important role. And the reactivity of metals, there is an order for it. And if you remember, you have learned an activity series for that. In this activity series, we arrange all these metals in order of their decreasing reactivity. The element which is going to be on top is going to be more reactive than the elements which are going to be below it. And what is the significance of this reactivity series is something that you learned while we were studying the displacement reactions in class 10th. I hope you all remember. There is a very frequently asked question in the examinations for class 10 students that if you have an iron nail, you put that into copper sulfate solution. What is the color of the copper sulfate solution? Well, that is blue in color. So if we put an iron nail in the copper sulfate solution, what we see after some time is that the color of the copper sulfate solution that disappears, and instead of that there is a light pale green color solution that we have. So what has happened over here? Well, iron, this reacts with copper sulfate to form FeSO4 and copper. Now what has happened? What has happened is, we can say this, that iron has displaced copper from its salt solution. And if you compare this in the reactivity series, we find that iron, this is higher than copper in the activity series. So what we can say is that an element which is going to be higher in the activity series can displace the element which is below it in the activity series from its salt solution. Now, why I have revised this thing for you is because if you see hydrogen, this is quite below in this activity series, and all the elements which are above hydrogen now, they can displace hydrogen from water. Okay, so when I'm saying that we can prepare hydrogen by the action of water on metals. All the elements which are going to be of hydrogen in the activity series, they can displace hydrogen from water. Okay, now the elements which are going to be more reactive like potassium, sodium, calcium, they can easily react with cold water also and evolve hydrogen, whereas the elements as we go down, they are going to become less reactive, so we will have to use hot water, we will also have to use steam. So now with this understanding, let us see the various reactions. So first we have is the reaction of the metals with cold water, and when I'm saying cold water, it is a temperature of 7 to 25 degrees Celsius. So here what we see is that the active metals like we have potassium, sodium, calcium, they decompose water at room temperature to evolve hydrogen. For example, the reaction between sodium and water, this produces NaOH and hydrogen. Okay, similarly reaction between potassium and water is going to produce KOH and hydrogen, and these reactions, they are very fast and explosive reactions. In fact, when we see all the alkali metals, they can react with water to form the corresponding hydroxide and evolving hydrogen. Okay, and well, this is one of the reasons also where we call the group 1 elements as alkali metals, because all of them, when they react with water, they form the corresponding hydroxides or the alkalis. Okay, I hope you will remember this, because this is something again we will be talking about when we talk about the group 1 elements in the S block. Next, what we have is the reaction of calcium with water. So calcium and water, this is forming calcium hydroxide and hydrogen again, but this is a slow reaction in comparison to the reactions we have for the alkali metals. Now, again, when I'm talking about calcium, please do remember that all the alkaline earth metals, that is calcium, barium, strontium, they are going to react with cold water to form the corresponding hydroxide and release hydrogen. If I talk about magnesium, magnesium will be reacting with hot water and forming magnesium oxide and liberating hydrogen. The reaction I'm just now going to show that to you also. And there is one exception from the alkaline earth metals which is not going to react with water at all, and that is going to be beryllium. Okay, we will be talking in detail about all this when we will be discussing the alkaline earth metals, but just remember this. I was just writing those reactions, so I thought it is better that I just tell it to you this time also. Fine. Now, as I was telling you that the reaction with sodium and potassium, these are very fast and explosive reactions. The hydrogen which is going to be evolving, well, this can catch fire, and we do not want that. So what is the remedy for that? What we do is we take this sodium or potassium metal, we rub this with mercury. Okay, and when we are rubbing this with mercury, what is formed is the corresponding metals amalgam. Okay, any element in association with mercury, we call that as the amalgam of that element. So for example, if I rub sodium metal with mercury, what I will be getting is sodium amalgam. Now what we do is we do not rub the whole metal with mercury, we just leave some point, some metal surface unexposed, and then this is going to react with water. That unexposed metal is going to start reacting with water, form NaOH, and hydrogen will be liberated. But now, because all the metal is not reacting at the same time with water, so hydrogen will be produced slowly, so it will be a controlled reaction, and hence it will be a safe reaction. Okay, I hope this is now clear to you people. You will remember this. Now the next we have is the reaction with hot water, and when I'm saying hot water, it is going to be a temperature of 25 to 90 degrees Celsius, and I was just now telling you it is going to be less reactive metals like magnesium, aluminium, manganese, zinc, which will be reacting with hot water to liberate hydrogen. Okay, for example, if I say magnesium, this will react with water to produce magnesium oxide and hydrogen. So all these metals, they will be forming their corresponding oxides and hydrogen will be released. Next we talk about the reaction with steam now, and steam, this is going to be 100 degrees Celsius temperature and above. So here this is going to be very less reactive metals which are just slightly above hydrogen in the activity series, like we have iron, nickel, cobalt, tin and lead. They can be attacked by steam only. For example, if I give you a reaction of iron and water, it is going to react with steam. So iron is going to react with steam to form Fe3O4 plus hydrogen will be evolved, and Fe3O4, please remember, this is called as ferroso-ferric oxide, and this is the magnetic oxide of iron. The oxide of iron which has magnetic properties. So I hope this is clear how hydrogen is liberated on the action of water on metals. Right? This is very important. Many reactions they are going to come from this topic as your MCQ choices. So you should be able to choose the correct options wisely. So the next we have is, by the action of dilute mineral acids on metals, we can liberate hydrogen. So the metals which are going to be more reactive than hydrogen, these are the ones which react with dilute acids, and this is dilute acids and not concentrated acids, that we can use to liberate hydrogen. For example, zinc plus H2SO4, dilute H2SO4 will be giving us zinc sulfate plus hydrogen, and magnesium plus dilute HCl will be giving us magnesium chloride plus hydrogen. Now all these reactions, these are utilized for the laboratory preparation of hydrogen gas, and as we have to discuss the lab preparation of hydrogen in detail, I will be talking more about this when we discuss the lab preparation. Okay, first of all, I'm giving you all the ways in which we can get the different reactions. Then we will be discussing the lab preparation, although in the NCERT textbook you will be first having the laboratory preparation. The next we have is by the action of water on metal hydrides. Now one thing you can remember over here, which is just going to be helpful as far as your inorganic is concerned, that whenever we have written over here ide, okay, this means that this element over here which we have ide written along with it, this is going to be present in its elemental form. Okay, so this is going to be just hydrogen with metal. So metal hydride. If it would have been a nitride, it would have been only nitrogen. So you can distinguish this as nitride, nitrate, nitride. So whenever this is a ide written over here, it is going to be just that element. It is not going to be having oxygen with it. Whereas if it is a ide and a ate, there is also oxygen present with that element. This is just one way you can remember these things. So we have the metal hydrides, the metal in combination with hydrogen only now. There is going to be just these two now. Fine. So we have metal hydrides which are good reducing agents. They react with water to produce hydrogen. For example, lithium hydride on reaction with water will be producing lithium hydroxide plus hydrogen. Calcium hydride is going to produce calcium hydroxide plus hydrogen. And do remember that calcium hydride, this is called as hydrolith. Okay. And then we have sodium borohydride. So this is sodium, boro, these two elements along with hydrogen. Fine. So please do remember, this is an easy way to remember about the various compounds. You just do not have to mug up many formulas. So we have sodium borohydride combining with water to give us sodium metaborate and hydrogen. And this reaction over here, which has sodium borohydride, you will be seeing that we will be using a lot of sodium borohydride while we are going to study about organic reactions. This is a very good reducing agent for organic reactions. So the next way why we can prepare hydrogen is by the action of alkalis on the amphoteric elements. And what are amphoteric elements? These are going to be those elements which can react both with acids as well as bases. So the common amphoteric elements, they are zinc, aluminium, lead, tin, antimony, etc. When they are going to react with the alkalis, they will be producing hydrogen. Okay, for example, let us see the reaction between zinc and NaOH. When they are going to react, what is going to be formed? Sodium zincate plus hydrogen. So Na2ZnO2, this is called as sodium zincate. And you've already studied the reaction of zinc with dilute H2SO4 forming zinc sulfate and hydrogen. So zinc, this is reacting with both NaOH, that is a base, as well as H2SO4, which is an acid, to form the corresponding salt and hydrogen being evolved. Right. Similarly, let us see the other amphoteric elements as well. So we have tin, which reacts with NaOH and water to form Na2SnO3 plus hydrogen, which is sodium stannate. Right. And if we are going to have a reaction of tin, for example, with dilute HCl, it will be forming tin chloride and hydrogen will be evolved. Okay. Next we have is aluminium, NaOH and water forming sodium meta-aluminate NaAlO2 plus hydrogen. Okay. And if we talk about aluminium reacting with the dilute HCl, it will be what? It will be aluminium chloride plus hydrogen. So the acids, they are going to be very easy. I have written down all the formulas for the corresponding salts with the alkalis, because these formulas, they are going to be very important for you to remember. Okay, they can even come as direct formula question also in the examination. So the next we have is the reaction of lead with NaOH and water forming sodium plumbate and hydrogen. Silicon, this reacts with NaOH and water to form sodium silicate and hydrogen. And beryllium, this is also an amphoteric element, this reacts with NaOH to form sodium berylliate and hydrogen. So please do remember all of these. All these, they are amphoteric elements. They will be reacting with the acids also, and that will be dilute acids. Again, please do remember that they are reacting with the dilute acids, and all these reactions, they are utilized for the laboratory preparation of hydrogen. So now let us in detail discuss the laboratory preparation of hydrogen. So in the laboratory, hydrogen, this is prepared by the action of dilute sulfuric acid on granulated zinc taken in the Woulfe bottle, and the reaction you've already learned now, zinc plus dilute H2SO4, this is going to form zinc sulfate and hydrogen will be evolved. So this is the experimental setup for the experiment, and here we have the Woulfe bottle. In this there is a thistle funnel which is fitted, and from this we pour in dilute sulfuric acid, and here we have granulated zinc taken in the Woulfe bottle. So both they are going to react, and in the process what is going to be evolved? Hydrogen will be evolved, which will be passing through this delivery tube, and this will be collected by the downward displacement of water. Water will keep on coming down, and hydrogen, this will be collecting on top. Right, this is as far as the experiment is concerned. But now there are going to be certain things which are going to be very important for this experiment that you should know. What are they? Let us understand them. First is that we do not take pure zinc in this experiment. Why? Because it reacts very slowly with dilute H2SO4. What we do is we take impure zinc, which speeds up the reaction by forming electrochemical couples. Next thing that you have to remember is that we do not use concentrated H2SO4 for the experiment. We always take dilute H2SO4. Why we do not take concentrated H2SO4 is because hydrogen which is going to be produced, this reduces H2SO4 to sulfur dioxide. Okay, now here you can remember one more thing. If you have studied the last lecture while I was talking about the different forms of hydrogen, there what we discussed was that whenever there is a chemical reaction occurring, the hydrogen which is liberated from its salt, that is called as nascent hydrogen the moment it is being liberated, right? So in this reaction, zinc plus H2SO4, when this H2SO4 will break, what will be formed? It will be nascent hydrogen. Okay, now when it is dilute H2SO4, this is a non-oxidizing acid, right? So the nascent hydrogen which will be formed, they will quickly combine with each other. Nascent hydrogen, it has a very short life, and they will be resulting in the formation of H2 along with zinc sulfate. Fine. But when we have concentrated H2SO4, this is an oxidizing acid. So what will happen is that nascent hydrogen that will be formed, that will react with H2SO4 further to form sulfur dioxide and water. Okay, so what we will be getting as a reaction of zinc and H2SO4 concentrated is zinc sulfate, sulfur dioxide and water instead of hydrogen, which we were trying to prepare in the laboratory, right? So we will not use concentrated H2SO4. Next thing is that sometimes bubbles of hydrogen gas which will be liberated, they get adhered to the surface of zinc granules which prevent further reaction. So to avoid this, we add a small amount of copper sulfate to the reaction mixture. Please do remember this as well. Now, you please do remember that along with dilute H2SO4, we can also use for the same experiment dilute as well as concentrated HCl. And here the reaction is going to be zinc plus HCl forming zinc chloride plus hydrogen. But remember always that we never use HNO3 nitric acid for this experiment. Neither dilute nor concentrated HNO3 they can be used for the reaction because of the resulting reduction to the oxides of nitrogen. What I mean is, let me show you with the help of the reactions. So we have zinc reacting with HNO3 to form zinc nitrate and nascent hydrogen. Now, what happens is this nascent hydrogen, this can react further with HNO3. If this is concentrated HNO3, what will be formed is correspondingly NO2 and water. And if it is dilute HNO3, what will be formed is NO plus water. So the oxides of nitrogen are formed rather than hydrogen being evolved. So we do not use dilute or concentrated HNO3. We neither use concentrated H2SO4. You can use only dilute H2SO4 or you can use hydrochloric acid for the preparation of hydrogen. Okay, please do remember this. But there is one exception over here where we can use dilute HNO3 also for the preparation of hydrogen, and that is when we use manganese and magnesium. Either manganese or magnesium, when they are reacting with dilute HNO3, they will be producing hydrogen. The reaction, for example, for magnesium is going to be magnesium plus HNO3 forming magnesium nitrate plus hydrogen. Okay, so this is as far as the laboratory preparation of hydrogen is concerned, and also just like we have done for the reactions with the alkalis also, right? So zinc plus NaOH, that is forming sodium zincate plus hydrogen, that is also used in the laboratory preparation. So these are the certain important reactions that you have to remember over here. The next we have is the industrial preparation of hydrogen, the commercial preparation of hydrogen or preparation of hydrogen on a large scale. And this is going to be very important. Again, many questions they are being framed from this topic, so it is going to be very important for you. The first way in which we can prepare hydrogen in the industry is by the Bosch process. And here what is being done is that coke, which is a form of carbon, this is heated to about 1270 Kelvin, made red hot, and then steam is passed over it where a mixture of carbon monoxide and hydrogen is produced, and this is known as water gas. Very frequently this question comes in the examination. What is water gas? So water gas is a mixture of carbon monoxide and hydrogen. So the reaction is carbon in the form of red hot coke plus steam is giving us a mixture of carbon monoxide and hydrogen, which we call as water gas. Now, what is the basic purpose of this reaction? What are we preparing? We are preparing hydrogen. So now, what we want is to have a maximum yield of hydrogen. We are preparing hydrogen on a commercial scale. So what we do is that we pass this water gas with more, mix this water gas with more of steam in presence of Fe2O3, which acts as a catalyst, and Cr2O3, which is acting as a promoter, and this converts carbon monoxide into carbon dioxide and we get more of hydrogen, and this is known as water gas shift reaction. So the reaction is passing of water gas through more steam in presence of a catalyst and promoter and getting carbon dioxide and more of hydrogen. Again, this is a very frequently asked question. What is water gas shift reaction? You will be given few options and out of that you have to choose one. Then another way which the question can be coming to you in the examination is which of the following reactions is going to increase the production of hydrogen from water gas. Okay, so these are the ways the questions they are coming, and this is a really important reaction, very frequently coming in the examination. Now what we have got now is carbon dioxide and hydrogen. What do we need? We need is hydrogen and not carbon dioxide. So what we do is that carbon dioxide, this can be removed by scrubbing with sodium arsenide solution, or another way in which we can remove carbon dioxide is by passing the mixture of carbon dioxide and hydrogen through water under pressure. And what is going to happen is that carbon dioxide, this can get dissolved in water. So carbon dioxide will get dissolved in water and hydrogen gas will be set free. So this is how we are getting the hydrogen free from the carbon dioxide which is associated with it. Now, one thing you have to remember over here is that water gas, this is also called as syngas, or in full form it is called as synthesis gas. Okay, why it is called as synthesis gas or syngas? Because this is used for synthesis of methanol and a large number of hydrocarbons. So it is called as syngas. Again, a very frequently asked question. What is syngas? What is another name for water gas? And so on. So these are a few questions which are coming in the examination very frequently. That is why I'm laying a lot of stress. Okay, so this is used for the synthesis of methanol and a large number of hydrocarbons. Therefore, this is called as syngas. Now, please do remember that syngas nowadays, this is also produced from sewage, sawdust, scrapwood, newspapers, etc. So that would be the best out of waste. All the waste products being utilized for the production of syngas or water gas. Here, one more term that you have to remember is coal gasification. From coal, a gas being produced. So the process of producing syngas from coal, this is called as coal gasification. Along with coke, we can also produce syngas by the reaction of hydrocarbons with steam. And when I'm saying hydrocarbons, it is going to be the petrochemical products that we use for the production of water gas. So here you have the alkanes, the general formula CnH2n plus 2 on reaction with water at a temperature of 1270 Kelvin in the presence of nickel as the catalyst, reacting to form carbon monoxide and hydrogen mixture, that is nothing but water gas. For example, when we use methane or natural gas, it is going to react with water, again the same temperature and catalyst conditions to form water gas. And when I'm saying that the petrochemicals, they are used for the industrial preparation of hydrogen, please do remember that in fact 77% of the industrial hydrogen, we are preparing it from the petrochemicals. Okay, and it is only 18% of the industrial hydrogen we are preparing from coke, and the rest 4% you will be getting it by the electrolysis of water, which you will be studying on the next slide, and only 1% is going to be from the rest of the processes. Now on this slide there is one more reaction that we can also use methanol for the production of water gas. So methanol at a temperature of 673 Kelvin in presence of a catalyst, when we are going to heat this, it is going to form carbon monoxide and hydrogen, that is water gas. And actually the opposite reaction is very important for us. Carbon monoxide, when this reacts with hydrogen, this produces methanol, and that is why we call this as syngas. What the use of water gas in the production of methanol and other organic compounds is why we call water gas as syngas. You will be seeing that reaction when we will be talking about the properties of hydrogen. So the next method by which we can produce hydrogen on the commercial scale is the electrolysis of water, and here acidified water on electrolysis using platinum electrodes, this gives hydrogen. So water on ionization, this is going to produce H ions and OH ions. H ions, they will be utilizing electrons to form hydrogen at the cathode, whereas the OH ions, they will be moving on to the anode, where they will be releasing 4 electrons and forming water plus oxygen being liberated at the anode. Okay, so this is what we have as far as the electrolysis of water. Now one thing that you have to remember over here is that we are always using acidified water, or you can also alkalize the water. 15 to 25% of an acid or alkali in the water is essential for the electrolysis of water. We never use pure water for the electrolysis purposes because it is not a good conductor of electricity and hence not deemed fit for the electrolysis. Ionization is going to happen only in presence of an acid or an alkali. The next we have is the electrolysis of barium hydroxide solution, or you can say the electrolysis of water, which consists of barium hydroxide. Okay, and why we are using barium hydroxide is because we want high purity hydrogen at the order of 99.95% pure hydrogen is what we get when we do an electrolysis of barium hydroxide solution. Why we are using barium hydroxide in preference to NaOH or KOH during the electrolysis of water is because if any carbon dioxide is present, it will be absorbed by barium hydroxide, and when it is being absorbed by barium hydroxide, what will be formed is barium carbonate, which is insoluble. It will be forming a white precipitate, it will settle down and it will not interfere with the electrolytic process. So barium hydroxide on reaction with water, carbon dioxide, this forms barium carbonate, a white precipitate, and water is going to be now safe and very pure to do the electrolysis and produce hydrogen. Okay, so for high purity hydrogen, we do an electrolysis of an aqueous solution of barium hydroxide. Please do remember this. This has been once asked in an IIT examination question. So now a question can be asked to you, how to can obtain pure hydrogen. So one of the ways I've already told you, so I will be putting that on the last point. So we can prepare pure hydrogen by the action of pure dilute HCl on magnesium, action of caustic potash KOH on scrap aluminium, which is called as UNO's method, action of water on sodium hydride, and lastly what we've already discussed, the electrolysis of barium hydroxide solution. This is the most preferred method because here we will be getting 99.95% pure hydrogen. So the next process by which we can do a commercial preparation of hydrogen, this is known as Lane's process, and this alternating currents of steam and water gas, they are passed over red hot iron to produce H2. Okay, and this process, this has two stages. The first stage is called as the oxidation state or the gassing reaction. In this, the red hot iron, the iron which is maintained at a high temperature of 1025 to 1075 Kelvin, this is reacting with steam. The iron oxide, which is magnetic oxide or ferrosulfuric iron, Fe3O4, this is produced along with hydrogen. Okay, now this reaction is allowed to proceed for about 10 minutes, in which whole of the iron, this gets converted into the magnetic oxide. After this, the supply of the steam, this is cut off so that this reaction is going to stop. And why we want to stop this reaction at this stage is because whole of the iron has been converted into the oxide, and now it would be the step where we would be regenerating the iron again. Okay, so the second stage, this is called as the reduction state or vivifaction reaction, where we are going to have a regeneration of the iron which has been consumed now. So here the reaction of the magnetic oxide is going to take place with water gas. So Fe3O4 on reaction with carbon monoxide of the water gas is going to form iron plus carbon dioxide, and it is also going to react with hydrogen of the water gas to produce again iron and water. So we are regenerating the iron. So now this reaction is allowed to carry on for about 20 minutes. So that we can have now a continuous supply of this hydrogen, what is done is that two or more than two furnaces, they are used at the same time. One is supplying hydrogen, the other may be in the phase of the regeneration of iron. So this way we get a continuous supply of hydrogen by this process. The next commercial way of producing hydrogen is actually as the byproduct of many manufacturing processes. For example, in the manufacture of caustic soda by the electrolysis of sodium chloride solution, which is called as the Nelson cell method, hydrogen is produced as a byproduct. We will be talking more about this when we will be studying the course on the alkali metals in the S block elements. Okay, and it is also produced as a byproduct in the manufacture of sodium metal from fused caustic soda, and the process is called as Caster-Kellner cells. So this again we will be talking more about when we will be studying the S block elements, the second course for inorganic chemistry for class 11th. So that would be an end to the learning part of the lecture today, and now we are seeing the lecture review questions. There are going to be 5 multiple choice questions over here for which you have to put your answers in the comment section. They are based on the learning of this lecture, so I would like to know how much you have gained from this lecture, and you should also know how much you have gained from this lecture. Right? So the 5 questions are, the first one being, which of the following combinations will produce hydrogen? Iron metal and concentrated HNO3, copper metal and concentrated HNO3, zinc metal and NaOH, gold metal and NaCN in the presence of air, and this question was asked in JEE Advanced 2017. The next question is, the metal that gives hydrogen gas upon treatment with both acid as well as base is iron, magnesium, zinc and mercury, and this question was asked in JEE Mains January 2019. The next question is, very pure hydrogen 99.9% can be made by the which one of the following processes? Reaction of methane with steam, mixing natural hydrocarbons of high molecular weight, electrolysis of barium hydroxide solution, reaction of salts like hydrides with water, and this question was asked in AIEEE 2012. So this is what JEE Mains was before JEE Mains came into being, All India Engineering Entrance Examination for the year 2012. The next question is, the synonym for water gas when used in the production of methanol is syngas, natural gas, fuel gas and laughing gas, and this question was asked for JEE Mains January 2019. So the last question that I have for you today is that which of the following reactions is an example of use of water gas in the synthesis of other compounds? Methane plus water forming carbon monoxide and hydrogen, carbon monoxide, hydrogen and water forming carbon dioxide and hydrogen, CnH2n plus 2 forming methanol in presence of cobalt as a catalyst, and carbon monoxide and hydrogen in presence of cobalt as a catalyst forming methanol, that is CH3OH. And this question was asked in the NCERT exemplar textbook. Right, so these are the questions which I have for you today, and I am waiting for your answers. So that would be all for this lecture. The next lecture we would be discussing the properties, that is the physical properties as well as the chemical properties and the uses of hydrogen. Now if you like the lecture, please do click on the like link before leaving, and also please do subscribe to the channel and click on the bell icon so that you get a notification the moment we put up the next lecture for you. So see you again. Have a nice day. God bless you.